In this video, we're going to learn about hexadecimal numbers and how to convert hexadecimal numbers back into decimal. So the hexadecimal number system is what is called base 16. So what's really cool about these base 16 numbers is we can represent decimal numbers in less digits because it is base 16 where decimal is only base. So it still works in the same way. It's all based on powers of a number, in this case 16. So we have 16 to the power of 0, which is 1, to the power of 1, which is 16, to the power of 2, which is 256, to the power of 3, which is 496, and to the power of 4, which is 65,536. So you can see that powers of 16 grow quite quickly. So knowing the powers of 16 is your first important piece of information on this slide. The second piece of information you need to know is that hexadecimal numbers need to have 16 possible digits to go in these different slots. Now, the tricky part is we have the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are our numbers in the decimal system, and those represent the first 10 digits in the hexadecimal system. But we need more possible digits to go into these slots. So we actually utilize letters to represent these. So we have A, which is essentially the equivalent of representing 10, B, which is the equivalent of 11, C, which is the equivalent of 12, D, which is the equivalent of 13, E, which is the equivalent of 14, and F, which is the equivalent of 15. So you now see that we can represent 0 through 15, so that's 16 total digits, by using 0 through 9, and then A, B, C, D, E, F for the remaining 6 digits that we need to make this base 10. So let's take a minute and practice this together. So here we can see we have our list of the first couple powers of 16. And so we're going to go through and we're just going to label each digit and what that space represents. So the A represents the number of ones that we have. The 9 represents how many 16s we have. The E represents how many 256s we have. And the 5 pairs with 16 to the power of 3, which is 4096. So we now know what each represents. So let's also think through the letters here because we need to know what the letters represent. So I remember that A is equal to 10. So this is actually equal to 10 here. And then B is 11, C is 12, D is 13. So that means E is equal to 14. So this E right here is really equivalent to the number 14. So we're going to go through and we're just going to say we're going to multiply all of the necessary numbers together because remember this 5 really represents the fact that we have 5 4096s, so we're going to label that. We then have 14 256s. We then have 9 16s, and then we have 10 ones. So now we can utilize a calculator to multiply these out. So 5 times 4096 is 20,480. 14 times 256 is 3,584. 9 times 16 is 144, and then 10 times 1 is 10. So if we add all of these together, so we take 20,480 plus 3,584 plus 144 plus 10, we end up with a decimal number that is equivalent to 24,218, and that will be in base 10. So you can see that we can represent 24,218 with less digits here in hexadecimal. We can represent it with 4 digits instead of 5. So it allows us to save some space as we are saving numbers and representing numbers. So what I'd like you to do on this slide is take a few minutes and practice converting numbers from hexadecimal into our decimal number systems. You'll notice all of these are written in hexadecimal. Some of them contain letters. But please take the time to pause the video, practice these, make sure you can convert them on your own, And once you feel like you've got some solid answers, you can unpause the video and go check your answers on the next slide. So now that you've converted these on your own, take a minute and check your answers. Make sure that you can accurately convert numbers from hexadecimal into decimal and that you understand that process. And if you have any questions, please make sure that you seek support before moving on.